Electrical discharge machining. It is a process in which electrical energy is used to generate a spark between the tool and workpiece submerged under the dielectric medium so that material removal takes place from the surface of the workpiece by local melting or vaporization called as electrical discharge machining. Electrical discharge machining diagram. It consists of pulse generator, workpiece, fixture, dielectric fluid, pump, filter, tool holder, spark generation, tool. Working principle of electrical discharge machining process. The workpiece is fixed in the dielectric container using fixture. The tool is fed up by the servo feed unit which can move downward in a vertical direction. The power supply is given to the electrical discharge machining process, that is, positive terminal is given to the workpiece and the negative terminal is given to the tool. The tool and workpiece are separated using dielectric fluid and the optimum gap is maintained between them. As stated above, that at normal condition, the dielectric field acts as an insulator. In this sense, no electrical conductivity is taking place. But by an increase of high pressure, the dielectric fluid ionizes into negative and positive ions. The positive ions are attracted to negative ions and the negative ions are attracted to positive ions and thereby the heat is generated. When positive and negative ions collide with each other, then the spark is generated between the tool and the workpiece, which can remove the material from the surface of the workpiece. When there is no spark in the container, then the dielectric fluid again acts as an insulator. The same procedure is repeated to remove the material from the surface of the workpiece. Advantages of EDM. The machining process does not depend upon the mechanical properties of the workpiece. No residual stresses will be generated because no force are acting. The deeper hole is possible to produce L by D up to ratio up to 20. The surface finish is better due to melting and vaporization. Limitation of EDM. Workpiece material must be electrically conductive. Perfect square corner holes are not possible to produce. Hardening of the workpiece takes place near to the hole. Application of EDM. It is used for producing hole size less than 0.1 mm. Used for die sinking or die manufacturing. Holes in the air brakes or pneumatic brakes were done by an electrical discharge machining process. These are all about EDM. Thank you. We already learned about what is EDM. Here we are going to learn about wire cut EDM machine. Uses thin brass or copper wire as an electrode. Makes possible cutting most shapes and counters from flat plate materials. Complex shapes, tapers, involutes, parabolas, and ellipses. Process commonly used for machining tungsten carbide, polycrystalline diamond, polycrystalline cubic boron nitride, pure molybdenum, difficult to machine material. This is the diagram of EDM wire cutting. Process of wire cut EDM. Uses CNC to move workpiece along X and Y axis in a horizontal plane toward vertically moving wire electrode. Electrode does not contact workpiece but operates in a stream of dielectric fluid directed to spark area between work and electrode. When in operation, dielectric fluid in spark area breaks down, forming gas that permits spark to jump between workpiece and the electrode. Eroded material caused by spark washed away. Operating system. Four main operating system of wire cut electrical discharge machines. They are servo mechanism, dielectric fluid, electrode, machine control unit. Advantages of wire cut EDM. Process is burr free, thin, fragile section easily machined without deforming. Process is automatic, servo mechanism, advanced electrode into work as a metal removed. One person can operate several EDM machines at one time. Better dies and molds can be produced at lower cost. A die punch can be used as an electrode to reproduce its shape in machining die plate, complete with necessary clearance. Limitation of EDM. Metal removal rates are low. Material to be machined must be electrically conductive. A rapid electrode wear can become costly. Electrodes smaller than 0.003 inch in diameter are impractical. Laser beam machining LBM. A laser beam is a non-conventional machining method in which the operation performed by the laser. The laser stands for light stimulated emission of radiation. The process used thermal energy to remove the material from the metallic surface. This is the diagram of LBM. Laser beam machining working principle. In this process, the laser beam is called monochromatic light, which is made to focus on the workpiece to be machined by a lens to give extremely high energy density to melt and vaporize any material. The laser crystal ruby is in the form of a cylinder as shown in the above figure or diagram with flat reflecting ends which are placed in a flash lamp coil of about 1000 watt. The flash is simulated with a high intensity white light from xenon. The crystal gets excited and emits a laser beam which is focused on the workpiece by using the lens. The beam produced is extremely narrow and can be focused to a pinpoint area with a power density of 1000 kilowatt per centimeter square, which produces high heat and the portion of the metal is melted and vaporizes. Advantages of LBM. Any material can be machined including non-metal. There is no direct contact between tool and the work. There is no tool wear. Soft materials like rubber, plastic can be machined. Disadvantages of LBM. The overall efficiency of machining is very low. It is limited to thin sheets. It's having a high cost. A very low rate of metal removing. Application of LBM. Mass macro machining production can be done. Selective high treatment of materials. This is used in surgery. Micro drilling operation can be done. Characteristics of LBM. Metal removal techniques. Heating, melting and vaporizing by using high intensity of laser beam. Work material. All materials except having high conductivity and high reflexivity. Tool. Laser beam with wavelength range between 0.3 to 0.6 mu meter. Power density maximum about 10 power 7. Output energy 20 joule. Efficiency 10 to 20%. Metal removal rate 6 mm to 3 mm per minute. These are all about EBM. Thank you. Plasma arc machining PAM. Plasma arc machining employs a high velocity jet of high temperature gas to melt and displace material in its path, called plasma arc machining. This is a method of cutting metal with a plasma arc or tungsten inert gas arc. The torch produces a high velocity jet of high temperature ionized gas called plasma that cuts by melting and removing material from the workpiece. Temperatures in the plasma zone range from 20,000 to 50,000 degree Fahrenheit, that is 11,000 to 28,000 degree Celsius. Principle of PAM. In the plasma arc machining process, the material is removed by directing a high velocity jet of high temperature, that is 11,000 degree to 28,000 degree Celsius, ionized gas on the workpiece. This high temperature plasma jets melts the material of the workpiece. This is a diagram of PAM. Construction of plasma arc machining. A schematic arrangement of plasma arc machining shown in the figure. The plasma arc cutting torches carries a tungsten electrode fitted in a small chamber. This electrode is connected to the negative terminal of DC power supply, so it acts as a cathode. The positive terminal of DC power supply is connected to the nozzle, so it acts as an anode. A small passage is provided on one side of the torch for supplying gas into the chamber. Since there is a water circulation around the torch, the electrode on the nozzle remains water cooled. Working of PAM. When a DC power is given to the circuit, a strong arc is produced between the electrode and the nozzle. A gas, usually hydrogen or nitrogen, is passed into the chamber. This gas is heated to a sufficiently high temperature of the order of 11,000 degree to 28,000 degree Celsius by using an electric arc produced between the electrode and the nozzle. In this high temperature, the gases are ionized and a large amount of thermal energy is liberated. This high velocity and high temperature ionized gas is directed on the workpiece surface through the nozzle. This plasma jet melts the metal of the workpiece, and the high velocity gas stream effectively blows the molten metal away. The heating of the workpiece material is not due to any chemical reaction, but due to the continuous attack of plasma on the workpiece material. So it can be safely used for machining of any metal, including those can be subjected to the chemical reaction. Advantages of PAM. It can be used to cut any metal. The cutting rate is high. As compared to ordinary flame cutting process, it can cut plain carbon steel 4 times faster. It is used for rough turning of very difficult material. Disadvantages of PAM. It produces a tapered surface. The protection of noise is necessary. The equipment cost is high. Protection of eyes is necessary for the operators and the person working in nearby areas. Application of PAM. It is used for cutting alloy steels, stainless steels, cast iron, copper, nickel, titanium, aluminium, and alloy of copper and nickel, etc. It is used for profile cutting. It is successfully used for turning and milling of hard to machine materials. It can be used for stack cutting, shape cutting, piercing, and underwater cutting. Characteristics of PAM. Metal removal technique. Heating, melting, and vaporizing by using plasma. Work material. All materials that conduct electricity. Tool. Plasma jet. Velocity of plasma jet 500 meter per second. Power range 2 to 220 kilowatt. Current as high as 600 ampere. Voltage 40 to 250 volt. Cutting speed 0.127 meter per minute. Metal removal rate 145 centimeter cube per minute. These are all about plasma arc machining. Thank you. Electron beam machining (EBM). Electron beam machining is a thermal process used for metal removal, and the electrical energy is used to generate the electrons with high energy. Principle of EBM. When the high velocity beam of electrons strikes the workpiece, its kinetic energy is converted into heat. This concentrated heat raises the temperature of workpiece material and vaporizes the small amount of it, resulting in removal of material from workpiece. Types of EBM process. There are two types: machining inside the vacuum chamber, machining outside the vacuum chamber. This is the diagram of EBM. Construction and working of electron beam machining. Machining inside the vacuum chamber. Its construction. It consists of electron gun, diaphragm, focusing lens, deflector coil, work table, etc. To avoid collision of accelerated electrons with air molecules, a vacuum is required. So, the entire EBM setup is enclosed in a vacuum chamber, which carries a vacuum of the order of 10 to 5 to 10 to 6 mm of mercury. This chamber carries a door through which the workpiece is placed over the table. The door is then closed and sealed. The electron gun is responsible for the emission of electrons, which consists of following three main parts. 1. Tungsten filament, which is connected to the negative terminal of the DC power supply and acts as the cathode. Second, grid cup, which is negatively based concerning the filament. Third, anode, which is connected to the positive terminal of the DC power supply. Then, the focusing lens is used to focus the electrons at a point and reduce the electron beam up to the cross-sectional area of 0.01 to 0.02 mm diameter. Then, the electromagnetic deflector coil is used to deflect the electron beam to a different spots on the workpiece. It can also be used to control the path of the cut. Then we're going to see working of EBM. When the high voltage DC source is given to the electron gun, tungsten filament wire gets heated and temperatures rises up to 2500 degrees Celsius. Due to this high temperature, electrons are emitted from tungsten filament. These electrons are directed by a grid cup to travel downwards and they are attracted by the anode. The electrons passing through the anode are accelerated to achieve high velocity as half the velocity of light, that is 1.6 into 10 power 8 meter per second, by applying 50 to 200 kilovolt at the anode. The high velocity of these electrons are maintained until they strike the workpiece. It becomes possible because the electron travels through the vacuum. This high velocity electron beam, after leaving the anode, passes through the tungsten diaphragm and then through the electromagnetic focusing. Focusing lenses are used to focus the electron beam on the desired spot of the workpiece. When the electron beam impacts on the workpiece surface, the kinetic energy of the high velocity electrons is immediately converted into the high heat energy. This high intensity heat melts and vaporizes the work material at the spot of beam impact. Since the power density is very high, about 6500 billion watts per millimeter square, it takes few microseconds to melt and vaporize the material on impact. This process is carried out in repeated pulses of short duration. The pulse frequency may range from 1 to 16,000 Hz and duration may range from 4 to 65,000 microseconds. By alternatively focusing and turning off the electron beam, the cutting process can be continued as long as it is needed. A suitable viewing device is always incorporated with the machine, so it becomes easy for the operator to observe the progress of the machining operation. Second type, machining outside the vacuum chamber. Since the full vacuum system is more costly, the recent development has made it possible to machine outside the vacuum chamber. In this arrangement, the necessary vacuum is maintained within the electron gun and the gases are removed as soon as they enter into the system. Other processes are same as machining inside the vacuum chamber. Advantages of EBM. It is an excellent process for micro finishing milligram per second. Very small holes can be machined in any type of material to high accuracy. Holes of different size and shapes can be machined. There is no mechanical contact between the tool and the workpiece. Limitation of EBM. The metal removal rate is very slow. The cost of equipment is very high. It is not suitable for large workpieces. High skilled operators are required to operate this machine. Application of EBM. EBM is mainly used for micro machining operations on thin materials. These operations include drilling, perforating, slotting, and scribing, etc. Drilling of holes in pressure differential devices are used in nuclear reactors, aircraft engines, etc. It is used for removing small broken taps from holes. These are all about EBM. Thank you.